Okay, so welcome to this next video. We're going to be looking today at multiplication and the multiplication algorithm. So our learning goal, as normal, is the students will be able to solve problems involving comparison, addition and subtraction of integers. And what you're going to want to be able to do once you finish this is apply the associative and commutative laws to perform operations, apply different strategies to aid in calculation, and correctly apply the multiplication algorithm. Okay, so going into the second dimension. And when we're adding numbers together, if I got 3 blocks and added them to, say, 2 blocks here, I would have the 3 plus the 2. Okay, so let's say the 3 is red and the 2 is blue. Okay, so I just chuck them together, got a line of blocks now. Okay, so not really a big surprise. But what if I had instead the 3 here times the 2? What happens now is we still have our 3 sort of lined up here, but our 2 that we're multiplying by now gets sort of stacked up this way. So there's my 2, okay? And what happens is we create this area that now is sort of 6 pieces big, okay? It's 3 going this way, and it's 2 going this way. And this is called an array. Okay, so when we're multiplying, we're creating arrays, we're creating areas, okay? When we're adding and subtracting, we're sort of mucking around along a line, whereas when we move into multiplication, we're starting to create areas, we're starting to move out in different dimensions, okay? Right, let's have a look at a couple of the key ideas for us to look at here. So firstly, this symbol here tells us that we need to do the operation multiplication, okay? So if we see 7 times 6, that means we multiply these two numbers together. Okay? Now, as well, multiplication can also be described as the product of two numbers. Okay? So what that means is that rather than saying 2 times 6 or 7 times 6 or 7 multiplied by 6, you could say rather the product of 7 and 6. Okay? So your textbook sort of might refer to it like that a couple of times. You need to be aware of that. Okay? It might not be one you hear often, but you know, plug it up in your mind so you know what it means. Okay, now similar to addition, multiplication follows the commutative and the associative law. So remember, commutative was that idea that 7 times 6 is equal to 42, just as 6 times 7 is also equal to 42. Okay, so we can switch the numbers around with multiplication. Alright, it also follows the associative law, so 2 times 3 times 5. We can either do the 2 times 3 first and then get 6 times 5, which is 30, or we can go 2 times 3 times 5, do the 3 times 5 first and get 2 times 15, which is also 30. Okay, so it doesn't matter the order in which you carry out multiplication. Okay? Right, let's have a look at some strategies for your multiplication. So the first one, obviously, is your times tables. Now you might be thinking to yourself, oh man, that's just gross. I can't believe that Mr. Brady's talking about my times tables. But it's just going to help you to better quickly recall the multiplication facts. It's going to help you heaps later on with your factoring and your understanding of how the numbers are made up. It's going to be able to help you a lot in your maths career later on down the track. So there's some stuff on Hot Maths that can help you with that. You can get flip cards that can help you. I'm assuming there's probably some iOS programs you can have a shot at. But really, it's a good idea to be on top of your times tables up to 12. Okay? Right. You might want to have some good use of the associative and the commutative laws. So what that means is if you had maybe 7 times 6 times... actually, let's go with 7 times 2 times 6. Okay, now 7 times 2 is 14 times 6. You're like, oh, I don't really know my 14 times tables. So what you could do instead is go, well, I'm going to move some of these around and make the problem 7 times 6 times 2 instead. Now 7 times 6 is 42 times 2. Now that's a lot easier than 14 times 6 just to quickly do. Okay, and you'll be able to see this quickly, that's 84. Okay, so that's using your associative and commutative law as well. Okay, you could use the distributive law. Now, this is a little advanced, but more so because you've got to sort of partition things and hold things in your memory while you're calculating. But just say you had 27 times 8. You could rewrite that as 20 times 8 plus 7 times 8. Okay, so that's sort of breaking up this and getting the 2 and multiplying it by 8, or the 20 and multiplying by 8, and the 7 and multiplying it by 8. Okay, so 20 times 8 is 160, plus 7 times 8 is 56. So you'll have 216. Okay, so that's one way to go about that one. Okay, right. Moving on, you can also go have a look at the doubling and halving. So what this means is you can look at a problem like this and you might be able to quickly say, well, let's muck around with this 5 and this 6 a little bit. Okay, and what you might do is you can times the 5 by 2 and divide the 6 by 2. Okay, it's totally okay to do this. So 5 times 2 is 10 times 7 times 3, and that might be a much easier problem for you, especially since there's a 10 in there. It's 10 times 7 is 70, times 3 is 210. Okay, so that might be a lot more easy than this sort of original one here. Okay, so multiplying by powers of 10 is quite an easy one for you to get a hold of. So maybe 76 times 100. So 100 is a multiple of 10. What we do is we sort of look at how many zeros here. This is sort of the quick and easy way to do it. And we just chuck those on the end. Okay, so if there's no decimals to worry about, it's a very easy thing to do. So just sort of chuck those zeros on the end. 76 times 100 is 76, 0, 0. 2 zeros here because there's 2 zeros there. Okay, so to go, that's how multiplying by powers of 10 works. Okay. Now, using the multiplication algorithm, again, this is something that a lot of you have probably seen before, so I'll kind of fly through it. Right, if you see something like this, you can rewrite it as 254 times 6. So rearrange it like that. And we go about it by just successively multiplying this 6 against those different place values. Okay, so 6 times 4 is 24. Put the 4 there, carry the 2 up here. Now remember, that's an adding to, doesn't change this to a 7. Okay, so just be a little careful with that. Right, so 6 times 5 is 30, plus the 2 up here, so that's 32. 6 times 2 is 12, plus this 3 up here makes it 15. Okay, 1,524. Alright, similarly, when we get to our much larger multiplications for us to carry out, like this one here, things change a little bit, not by too much. Again, we write it 675 times 43, put our place values lined up. Okay, again, we sort of go through with this 3 and multiply it against all these different place values. 3 times 5 is 15, 3 times 7 is 21, plus another 22, 6 times 3 is 18, plus 2 is 20. Now, when we move on to this 4 to multiply against those 3, we're going to put a 0 down here, because we're actually multiplying by 40 now. So we put a 0 down there. 4 times 5 is 20. 4 times 7 is 28, plus 2 is 30. 6 times 4 is 24, plus 3 is 27. Right, and once we've got that, we're just going to add these up. 5 plus, so this is adding now. 5 plus 0 is 5, 2 plus 0 is 2, 0 plus 0 is 0, 2 plus 7 is 9, 29,025. So that's how I go about a longer multiplication algorithm. Now, as I said before, you've probably seen a lot of these different things before, and if this is very comfortable for you, I really encourage you to go straight for some of the should and could level questions rather than sort of sticking around in the must ones. Okay? Thanks for watching, and I'll see you at school for the exercises.